welcome again to chemistry. It's the second day. Today we look at significant digits, significant figures. Definition of significant figures: the meaning between the precision or certainty of a measure. Now, when I talk to my kids at where I teach, I tell them that there's a possibility they may never use this when they leave my class. If that's the case, oh well. But there's a good chance, a solid chance, that this may be something they use a lot in college. I get constantly emails back from former students saying that no one else in the class knows how to do this, and they're teaching everybody. So that's why I present it. I'll be using it all year as I teach. So it's a way of making sure that we are confident of the measures we're looking at. So again, significant digits, significant figures, or sig figs, it's a means to determine the precision and certainty of a measure. Now, we have specific rules we're going to look at. The first rule is that all non-zero digits are significant. What are we saying here? So if I have a number 2, 3, 4, 5, 0, because the 2 is not a 0, the 3 is not a 0, the 4 is not a 0, the 5 is not a 0, 0 is a 0. I have 1, 2, 3, 4. I have 4 sig figs there. Okay, and the number 0, 0, 3, 4, 5, I only have 3. Now what the 5, the 4, and the 3, and the 2 are telling me, this 0 is what we call a placeholder. Tell me how far the 5 is from the decimal place. So while they're important, they're not significant. Same thing here. I've got 2 zeros and a 3. These 2 zeros tell me that the decimal place is 2 away from the 3 sig figs. All right, now, zeros are not significant except, first of all, if they're between them. So if I have the number 1, 0, 0, 0, 3, 0, 0, the 1 is not 0, it's significant. 3 is not 0, it's significant. The 3 zeros between are significant, so I would have 5 sig figs. On the other hand, over here, I have these 2 placeholder zeros. They're not significant. The 4 and 5 are not 0, they're significant. 0 between are between, so they are significant. I have 4 sig figs. All right, hopefully that makes sense. All right, we can then say if a number is after decimal, and after a number, and after number, and after decimal, it's showing exactness, it's significant. So what are we saying? If I have a number 1.2, 0, 0, 0, 0, 0, 0, that means all the way out, 10th, 100th, 1000th, 10,000th, 100,000th, millionth, 10 millionth. I'm confident to my answer to the 10 millionth place. And so I'm certain of all those numbers, so I would have 1, 2, 3, 4, 5, 6, 7, 8 sig figs. On the other hand, over here, 10th, 100,000th, 10,000th, 100,000th, millionth, to the millionth place, I'm confident, but I only have 2 sig figs because this 2 is the zeros after a number and after a decimal. These 3 are just placeholder zeros. They're not giving me any certainty or confidence in the number. All right. Now, we also have to have a way of number that are greater than 10 being significant. So if I give you the number 13500000000, I have 2, 3, 4, 5, 6. This is significant. I have 6 sig figs because this is significant. Bar over makes it significant. These 3 are not 0, so they're significant. These 2 are between significant, so we have 6 sig figs there. All right. Now, Rule C does not apply to decimals. So what are we saying? Okay, if I have the number 0.004005 and I want 4 sig figs, I can't do that. That would be wrong. This bar rule only applies if a number is greater than 10. Less than 10, a decimal, we can't use that. So how would I make that have 6 sig figs if I wanted it? All right, would I go back to a prior rule? I'd add 2 more decimals to show exactness. Now I'd have 6 sig figs. Hopefully that makes sense. All right. So, and the last rule here, constants and equalities are significant. So we're saying 1 foot is 12 inches. Exactly 1 foot is exactly 12 inches. That's infinitely significant. We don't worry about sig figs, as many as we need. In addition, we have the value c, which is the speed of light in a vacuum, 3 times 10 to the 8th meters a second. That's an exact number. We can consider that infinitely significant. All right. Now, in terms of operations of math, we have addition, subtraction. For addition and subtraction, we take the last filled column to the right. That is your level of significance. So what are we saying? If I take the number 45.892 and 2.9. Last filled column, the number is going to be 48.792, but the last filled column here is the 10th place. You see that little number all the way down. That means to the 10th place. I'm confident. Now we look to the right. To the right we have a 9. The rule for rounding is 5 or greater, we round up. So the answer here would be 48.8. That would be my answer. Okay, now we addition and subtraction. We also have to have multiplication division. The rule for multiplication division is that, get this out of the way, you can see it better. The least number of significant digits in the problem is the most in your answer. So let's say I give the number 34.9 and divide that by 12.4. So when we multiply that through, I get 2.81451629. Now, I have 3 sig figs in 34.9. I have 3 sig figs in 12.4. Of 3 and 3, the least number is 3, so I can only have 3 in the answer. Answer is 2.81. The number to the right here is a 4. It's less than 5, so we drop it. 2.81 is my answer. All right, I've got a bunch of problems here. Why don't you pause the video, Ryan, try them out. What I want you to do for these 4 problems, I want you to figure out how many sig figs, and then do this math problem and this math problem. This one for addition, this one for multiplication. See what we come up with. Say, pause it now. Alrighty, so hopefully you did what I asked. Try the problems. Let's see what we get. If I do 324.0, that 0 is after a number, the 4 after a decimal, it's showing its exactness. I have 4 sig figs. For the number 301, the 3 and the 1 are significant, the 0 is between it. It's significant because it's a number between it. I have 3 sig figs. Okay, over here, 5, 9, 1, and 4 are all non-zeros. That's 4. The 0 is between. It's significant. I have 5 sig figs. Over here, I have 3 sig figs because the 2 and the 4, the 0 is after number, after decimal. It's showing exactness. It's significant. These 3 are placeholder zeros. When I add these up, when I take 15.2873 plus 8.90 and subtract 10.11111, I get 14.07619. Now the last filled column here is a 10th hundredths place. So we go to the 7. Look to the right of that. It's a 6. That's 5 or greater. Round up. Answer is 14.08. Now the last one. Take 12.293, divide by 4.0. I get 12.82325. I've got 5 sig figs. I got 2 sig figs. Of the 2 of these, the least number is 2, so the answer is 13. All right, let's try some more. Okay, I've got these here. For the first 4, I want you to tell me how many sig figs I have. For number 5, I want you to make 125,000 have 4 sig figs. And then I want you to make 0.0002 have 5 sig figs. And then for the last one, you see parentheses. So we're going to do each of these parentheses first. We're going to do this addition problem, okay, and follow the addition rule for subtraction, for addition. Then I'm going to do this subtraction problem, follow the rule for subtraction, and then we're going to multiply those 2 numbers. So we have 3 actual problems there, okay. Pause the video, try it, see what we come up with, and then we'll go over it. Okay, hopefully that's what it did. Let's give it a shot. Okay, so 1, 2, 3. This is significance of the line over. 1, 2, significant between 4, 5, 6, 7, 7 sig figs. That's infinite. Why? Because that's an equality. Remember, all equalities are infinitely significant. Add the 1 and 2. Those are significant, only significant. Okay, all the zeros, placeholder zeros. 0.000000. I got a little happy with the zeros there. 2, 1 sig fig. Okay, to make that have 4, it's greater than 0. I put a bar over that first 0. To make 0.0002 have 5, I add 4 zeros at the end. Remember, that's showing exactness. All right, for this one, when I add 35.8945 plus 4, I actually get 39.8945. But last filled column, for addition and subtraction, is going to come to the ones place. So therefore, it's going to be 39.989. That's greater than 5, so we'll round it up. but at 39 I have 2 sig figs. I need 2 sig figs, so I need to put a bar over the answer for 40. And when I subtract 0.2500 from minus 1.934, I get negative 1.684. When I multiply them, let's do the calculator here to get the exact number. 40 times negative 1.684. I get negative 67.36, but I have 2 sig figs here, 4 sig figs here. We have 2 sig figs in the answer. Negative 67 is my answer. Okay, what we're going to do next then is I'm going to give you a bunch of practice problems. I'll give you the practice problems. I'll show you the practice problems. I will do 2 or 3 with you, and then I will let you work through the rest of them, and then I'll post the answers. Okay, hopefully this helps you. Take care. God bless. Have a good day. Remember, chemistry is fun.